we are continuing in the goodness of fit test in our statistics OER course, and we will do one example from the Intro to Statistics book by OpenStax. Employers want to know which days of the week employees are absent in a 5-day work week. Most employers would like to believe that employees are absent equally likely during the week. Suppose that a random sample of 60 managers were asked on which day of the week they had the highest number of employee absences, and the results were shown in the table below. 15 managers said that most of their employees were absent on a Monday. 12 managers said that most of the employees were absent on Tuesday. 9 managers said that they were absent on Wednesday. 9 managers said that they were absent on Thursday, and 15 managers said that most of their employees were absent on Friday. These are the observed or reported frequencies. Now, in this particular problem, we are doing obviously a test at the level of significance alpha, and we want to know if absences for employees occur at highest numbers certain days of the week and at lowest numbers other days of the week. Our null hypothesis is that theoretically employers believe that the employees are absent equally during the week. So absenteeism occurs equally likely, or we can say uniformly each day of the week. And the alternative hypothesis is whether we believe or we want to prove that absenteeism is not uniformly over the days of the work week. For example, I would have claimed that Monday and Friday are more popular than the other days of the week. So we want to do this test. And we have 5 categories: Monday, Tuesday, Wednesday, Thursday, and Friday. We are comparing these groups to see if they are uniform or not. Uniform means that the probability for each day of the week to be a popular day to be absent will be 20%. So 20% times 5 days will be 100%. The probabilities will be equally likely. And between 60 managers or 60 employers, that would be that 12 of them would have said Monday is a popular day, 12 of them would have said Tuesday is a popular day, 12 of them will have said Wednesday is a popular day, 12 will say Thursday, and 12 will say Friday. So 20% of the 60 managers would each have said that particular day. Our next job is to find the differences observed minus expected, and those are (15 minus 12) and 12 minus 12 and 9 minus 12 and 9 minus 12 and 15 minus 12. And then we want to square these quantities observed minus expected, and that will equal to (3 squared, 0 squared, -3 squared, which would be positive, -3 squared, again positive 9, and 3 squared, positive 9. And then we want to divide these squared quantities by the expected value of 12 for each one of the categories to find the Pearson residual for each of the days of the week. And I have 9 divided by 12, which is 3/4 or 0.75. 0 divided by 12, 9 divided by 12, 9 divided by 12, and 9 divided by 12. If you remember, the chi-squared test statistic is the sum of those Pearson residuals. So if I would add 3/4 plus 0 plus 3/4 plus 3/4 plus 3/4, I would have found my test statistic chi-squared to equal 12/4 divided by 4, or 3. So my test statistic is equal to 3, and then I want to go in the chi-squared distribution. undefined probability. The degrees of freedom are k minus 1. K are my categories. There are 5 days in a week. So 5 categories minus 1, it will be 4 categories. The chi-square test is always an upper tail test. Well, for our purposes, it is an upper tail test. And the value of x is this chi-square test statistic that I found of 3. And I will end up with a p-value of 55.78%. And up here in my title, I can see that the probability your chi-squared statistic is greater than 3 is 55.78%. So this chi-squared statistic that is equal to 3 generates a p-value of 0.5578, which is greater than alpha, and actually 55.78% indicates that the observed or reported frequencies of employees being absent over the 5 days of the week are not an unusual outcome coming out of the theoretical distribution of the null hypothesis. So my decision is that I fail to reject the null hypothesis, and my conclusion is that at the 5% significance level, the sample data does not provide evidence to support the alternative hypothesis, which is the claim that absenteeism at work is not uniform across the 5 days of the work week. So instead of doing all of this math by hand, I would also like to use technology to do the math, especially when things become more complicated and the numbers are not as straightforward as this. So we will use 2 methods of technology. One is Excel and the other is ArtofStat. ArtofStat actually has a goodness of fit test app instead of us using the chi-square distribution. So let's start with my Excel. The variable is the day of the week that employees are absent, and I have 5 possible days. The observed frequencies were 15, 12, 9, 9, and 15. And here I'm going to have a sum of every column, and it correctly adds to 60. So let me copy it over. And I don't want this to be yellow, so let me put them back to blue. All right. So the theoretical probability, if you remember, was a uniform distribution. Uniform distribution breaks the probability of 100% into 5 equal categories. So 20%, and I can write it as a percent or I can write it as a decimal, straight down in each category. Hopefully they will add to a 1, which is 100%. The expected number is the theoretical proportion or theoretical probability times the total of the sample size. I do want, as I copy and paste this formula, for this total to always stay the same, 60. So I'm going to use here the dollar feature in Excel to keep that particular cell E12 the same all along. So I will just copy and paste. You see here that the 20% times 60 always gives me 12. 12 is 1/5 of 60. The next column, I want to calculate the difference observed minus expected. So observed for me is column E, minus expected for me is column G. And I'm going to copy that. We know that the residuals or the differences from the expected should add up to a 0 if we have done a good job. Then I want to square these residuals, so equal the column H squared. That will give me the numerator of the Pearson residual. And then I want to find the Pearson residual by taking the squared quantity that I found, the squared residual, and dividing it by the expected value. The expected number is 12 here, is in my G column. So I'm going to do that and copy down. And if you remember, the test statistic chi-squared is the sum of those Pearson residuals. So if I do a sum of all of these residuals above, then that will give me my chi-squared test statistic of 3, which is what I found. The degrees of freedom equals the number of categories minus 1. So I'm going to count the number of data observations that I have and then subtract 1. And for the p-value, I'm going to use the chi-squared distribution in Excel. I can use chi-squared dot dist, which returns the left tail probability, or I can use the chi-squared dist dot right for the right tail, which is what I want since I'm doing a chi-squared test. So chi-squared are measuring to see how large the differences are, and that generates a very large positive chi-squared value. So it's asking me for the x value first. I'm going to click on the test statistic that I found, comma, and then it's asking me for the degrees of freedom, which I have calculated right above there. And that is my p-value of 55.78%. My significance level alpha was given to me from the beginning, 0.05 or 5%. And if you remember, my null hypothesis was that absenteeism for employees follows a uniform distribution across the 5 days of the work week. And the alternative was that it does not follow a uniform distribution. So again, I was able to find the same values that I found when I did things manually. Let's go back to Art of Stat. Let's go under the web apps, and we want to scroll down to inference for comparing several groups. And here is the chi-squared test. So if I click on the chi-squared test, the tabs up at the top give me two options. One is the test for independence homogeneity, and the other is the goodness of fit. So I want to go in the goodness of fit. In our course, we will not do test for independence and homogeneity, but there will be an extra credit Excel project for you to do that, to do the test for independence. But in our class, we will be focusing on a goodness of fit test. Enter data as a contingency table, and you have 5 categories because you have 5 days in the week. Category 1 is Monday. Category 2 is Tuesday. Category 3 is Wednesday. Category 4 is Thursday. And category 5 is Friday. You will see that Art of Stat defaults to a uniform distribution. If you want to change that, if your null hypothesis is not a uniform distribution but something else, then you want to click on those boxes and change them. But for your counts, here you want to click on each one of them, delete the 0 and add the number. So 15, 12, 9, 9, and 12. And then you want to submit. And here you will see the table that we created in our notes, where it is horizontally laid out and not vertically like I did in my Excel spreadsheet. Monday, Tuesday, Wednesday, Thursday, Friday are horizontal. My observed counts are here. The proportions of the uniform distribution here was 20% in each category. I made a mistake. My Friday, you see how the total here says 57. I should have said that my Friday is 15. So let's fix that and submit again. There we go. So now we are back to our normal values. So 15, 12, 9, 9, and 15 for a total of 60. uniform proportions here, expected counts of 12, residuals of 3, 0, -3, -3, and 3 with a sum of 0. The null hypothesis stated as a mathematical expression that basically copies the props, the proportions in your theoretical distribution here. That's your null hypothesis that says the proportion for category 1 is 20%, category 2 is 20%, 3, 4, and 5 are all 20%. We found a test statistic chi-squared of 3, degrees of freedom were 4, and your p-value came to be 0.5578 or 55.78% on a right tail test. 55.78% is not an unusual outcome coming from this theoretical distribution that assumes the null hypothesis, so we don't have enough evidence to reject the null hypothesis.